Good morning students, myself Amita, and today we will discuss about first chapter motion of physics. In this chapter we have already done other topics like rest, motion, distance, displacement, speed, velocity and their differences, and also acceleration and graphs related to different conditions. After that we will today take derivation of equations of motion by graphical method. To derive our three equations of motion by graphical method, first of all we will consider our object which is moving with some amount of initial velocity, and after some time t its final velocity is v. It is uniformly moving. After covering distance as its acceleration is constant, that is a. In this diagram, along vertical we take velocity and along horizontal we will take time. Our OD is equal to AC. This value denotes the value of time. OA equal to DC. This denotes the initial value of the object, and OE is equal to the DB, which denotes the final velocity of the object. This is all about the graph. After this we find three equations of motion turn by turn. That is, first equation is v is equal to u plus at, second is s is equal to ut plus half of at square, and third v square minus u square is equal to 2as. In all these equations our u terms denotes the initial velocity, v denotes the final velocity, a denotes the acceleration, and s denotes the covered distance with time t. To derive first equation of motion, that is v is equal to u plus at, from velocity time graph we use the relation between the acceleration and slope of the graph. That is, acceleration of an object, that is a, is equal to slope of line AB. AB is our main line and another lines are imaginary lines. Then our A is equal to BC by AC. This gives the slope, means according to this main line we made this triangle. From this triangle here we have theta, and this theta is a angle which is called slope. That is always equal to tan theta is always equal to BC by AC, means ratio of perpendicular to the base. That's why here we take A is equal to BC by AC. Here we don't have any particular value of BC. That's why we divide BC in two parts, that is BD minus CD. Their values are given, and by AC the value of BD is our final velocity, that is BD from E to O. This is V and CD U and AC T. By arranging all these terms we get V is equal to U plus A T. This is our first equation of motion. Our next, that is second equation of motion, S is equal to ut plus half of at square. To derive this equation we again use velocity time graph. The same graph is using here, and in this, from this graph the distance traveled is always equal to the area of figure OABD, means OABD, the area of this part. The area of this part may be divided in two parts. First, the area of rectangle plus area of triangle. The area of rectangle, that is OA multiply with OD plus half of AC, that is perpendicular, multiply with base. This is the area of triangle, and by replacing the values of these terms, that is OA equal to U, OD equal to T plus 1 by 2 AC, AC equal to T, CB. For CB, we use the relation of acceleration from first equation of motion, that is A is equal to CB by AC or BC by AC. That is CB is equal to A multiply with AC, and the value of AC is equal to T. Here we get CB is equal to AT. We use this relation at this place and we get S is equal to AT plus half of AT square. After the second equation of motion, we derive third equation of motion, that is V square minus U square is equal to 2AS. To derive this equation, we again use velocity time graph. From velocity time graph, the distance travelled, that is S, is equal to area of trapezium OABD. The area of trapezium is given by the sum of two parallel sides multiply with height and divide by 2. The sum of two parallel sides. The sum of two parallel sides are, that is OA plus DB. Multiply with height this OD. OD divide by 2. By replacing the values of these quantities, OA is equal to U, BD equal to V, OD equal to T by 2. In our third equation, we don't have any value of time. That's why we replace the value of time by using the first equation of motion. From this equation of motion, we find the value of T. We get that T is equal to V minus U by A. By putting the value of T here, we get the formula of A plus B into A minus B, that is A square minus B square. Here A is represented by V and B is represented by U. Then S is equal to V square minus U square by 2A, or V square minus U square is equal to 2AS. Okay, this is all about the derivation of equations of motion by graphical method. Okay, thanks.